Okay, so we can go ahead and get started. I've been able to get the download. So I'd like to start out by welcoming everyone back. I want to introduce our speaker today. Marisa Conte is our Associate Director for Research and Informatics at the Taubman Health Sciences Library. She also does a ton of work with MJM behind the scenes with the journal to help us get indexed and our efforts in various different areas. She has also uploaded a document for us. So after she gets going with our talk, I'm going to re-upload that to the chat because I know if you join later, you sometimes can't always see that. So without further ado, Marisa, I'll let you take it away. Thank you so much.
Great. Well, thanks for having me. I always really enjoy working with you guys. I'm always very impressed that with everything else you have going on with your actual coursework and clerkships and research projects and things like that, that you make the time to try and put together a scholarly journal, and happy to do whatever I can or whatever my team can to support these efforts. So what we're going to do today is talk a little bit about publishing research data. And this is something that I've talked with the editorial board about in the past, but in a slightly different way. So what I'm going to do today is I am going to cheat a little bit and just do a quick introduction or reintroduction, as the case may be, to the Taubman Health Sciences Library, particularly with COVID in the last year. Some of you may not have actually had a chance to go into the library or meet or interact with any of the informationists. So I just want to give you a quick intro to some of the services and resources that we provide, especially those that are relevant to the work that you're doing around the journal. The second thing I want to do is just introduce very quickly what we're talking about when we talk about scientific data and research data management, and then spend some time on the context. So why are we talking about this? And this is, I kind of break this into the two camps of we have to talk about this and we want to talk about this. And I think that the we want to is actually becoming an increasing force in scientific and scholarly publishing, which is something that makes it particularly relevant for you and the work that you're doing. So then from there, we'll talk a little bit about what's going on with data in the publishing world. So the last time that I did this talk, things are really different now, and data has become much more prominent in a lot of different aspects of publishing that I hope you'll find interesting. And then the last couple minutes, I just want to talk a little bit about how can you use this information and where can you go from here? And also, what do you need to know about data as a member of the editorial board? How can you more effectively, perhaps review manuscripts or maybe encourage authors to supply data along with the manuscripts they're providing to you? I do plan for this to be pretty informal, so if you have any questions, please feel free to either raise a hand or just go ahead and interrupt. I've got a little gallery view on the side of my screen here, but I'm not sure how well people will show up. So Morgan, if you want to maybe just interrupt me if there's questions in the chat, or anyone can feel free to chime in at any time. Different from years past, what we're not going to talk about is actually how you would manage your own research data. So I tried doing this before and it turned into a very long presentation where I felt like I was trying to cram too much into a short period of time. So tonight, we're not going to talk about writing a data management plan. We're not going to talk about some of the best practices for collecting or documenting your data, or analyzing and documenting the data. And we're not going to talk about best practices and visualization. So as I'll mention in a moment or two, we do have resources to help with all of these. And if you are going to be working on your own research, whether it's something that you're writing up for publication in MJM or something that you're working on with a faculty mentor, please do reach out. You can contact me, or you can use the general group addresses on some of the next slides to reach out to the individual groups. But we're happy to help with all of these steps. It's just not something that we're going to be talking about tonight. So very quickly, a reintroduction to the Taubman Health Sciences Library. If you didn't have a chance last year because of the closure, I hope that you'll take advantage and walk on into the library and meet us one of these days. The building is gradually opening. We're coming back on site a little more slowly. They're phasing our re-entry in to keep building capacities down. So my first day back in the office will be August 16th, and most of my team will be back that week or the following week. But in the meantime, we're always available via email. We can set up Zoom talks, whatever works best for you. And some of the things that we can help with are if you're trying to find information in particular. So we've launched a new website over the last year, and we've also just started a new project with a new catalog on the back end. So some of the resources that you're used to might not be where you're used to finding them, or there may actually be cataloging errors keeping you from things. So again, if you're having problems accessing information resources, please do reach out and let us know. From the Taubman Libraries homepage, URL on the screen here, we do provide quick links to the most popular databases and resources that we find that you would use, including Clinical Key, PubMed, and things like that. So bookmarking our library homepage and scrolling down to those quick links is generally one of the fastest ways to get to our resources if you're not accessing them from the clinical homepage. I also want to talk a little bit about some of the specialized services that are relevant, particularly to what I'm going to be talking about this evening. And the first is a research data management research guide. So the link on this screen would take you to a guide that one of my colleagues and I developed and maintain about all different aspects of research data management. So if you do have questions about writing a data management plan, what funder requirements might look like, if you want more information about data visualization, this is a great place to start. It'll give you a lot of helpful links, and there'll be an email address on every page that you can use to contact us. One area in particular that you might be interested in is data visualization. And in addition to the research guide, we also have a My Video channel. My colleagues Marcy and Tyler have put together a great introductory series of videos about the basics of data visualization, and they're starting to work on more specific products. So I think that they've got some videos in about how to do some very simple visualizations that you might use in Excel or in, I know they're working on one for Google Sheets. They've got a lot of expertise with Tableau, data visualization in R, things like that. So if that's something that you're interested in, this is a good resource for you.
Actually,
another thing, oh, sorry. Yep, got a question?
Oh, I was just saying, we actually sent out a link for that to everyone last month.
Oh, perfect. Yeah, they do really good work. And I know that their email address is always very active with questions coming in about specific projects. So it's a great resource to point your authors to as well. If you feel like maybe you've received a paper where the story could be told visually a little bit more compellingly than it's being told, it's a good place to refer authors for some help. Another thing I'd like to talk a little bit about is research impact. And this is a very broad area that encompasses everything from individual article level metrics, which is basically an indication of how many times a paper has been perhaps downloaded or perhaps cited in another work. But this is something, particularly as junior investigators or junior researchers, if you do plan to make this more of a part of your career moving forward, setting up your own research profile and being able to track your different scholarly achievements is something that's going to be really valuable for you, particularly as you start to think ahead to putting together residency applications and things like that. So we have a research impact core that talks about all of the different ways that you can qualify and quantify the impact that your research is having, not just based on traditional article level metrics, which is something that we'll talk about with the journal, but also using some of the alternative or alt metrics around social media mentions and appearances in news media and things like that. So the research impact core is a great place to start. If you're looking at something as basic as setting up a researcher ID or ORCID, which we'll talk about for your authors, or if you want to talk about how to embed different types of article level metrics and things like that into the journal itself. Research impact is important for authors, but it's also important for editors because you do want to be able to provide some value back to the people that are contributing to your journal, and helping them to build up researcher profiles can be a great way to do that. Any questions about what we ran through really quickly there? Give a minute.
Not seeing anything so far.
Great. Okay, I'm going to keep moving. So jumping into research data now, we've got two whats to cover. So what are we talking about when we talk about research data or scientific data? And then what are we talking about when we talk about research data management? So a couple of years ago, I'd say that it was a little bit harder to pin down what we were talking about when we talked about scientific data. We always referred back to the NIH definition because this is what they use. The bold part at the top, they define scientific data as the recorded factual material commonly accepted as necessary to validate and replicate research findings. So what a lot of researchers think when they hear that they have to share their research data is they assume that they're going to be expected to kind of turn over their entire lab notebook related to an experiment or a series of experiments in order to get an article published. And really, that's not what we're looking for. When people are talking about sharing research data, they're almost always talking about maybe data that's used to substantiate the results in a publication or in a manuscript that's being submitted for publication. Things are starting to open up a little bit more where there is more interest in things like shared notebooks and things like that. But really, again, at the moment, we're really looking for final research data when we're talking about sharing data along with publications. It's important to distinguish between these because there's 3 different flavors of terms floating around, and it can be hard for researchers to tell them apart. So data sharing, again, is making a subset of your data available, generally because of a publisher mandate or a funder mandate in order to support the work that you're reporting on. Open data is one step further, where you're taking maybe a broader corpus of data and you're sharing that maybe a little bit more freely. Maybe there aren't as many restrictions. Maybe it's available in a repository for anyone to use for any reason, as opposed to researchers having to contact the investigators and provide a reason and then get an access pass from there. And then the piece that I think is becoming even more prominent is the idea of open science. And the idea behind open science is that the final research product of a paper and the data set that supports that paper is really only a very small piece of what's probably a much more interesting story. If you can see things like the protocols and all of the raw data beyond what makes it into publication. And I think that journals in particular are starting to look more at this open science piece as they look for ways to expand their publishing portfolio beyond just the final results. Part of this, I think, is because there's been such a stir, especially recently, about a lot of publications that have to be retracted because it turns out that data were falsified, or that there was research misconduct, whether it was deliberate or whether it was not intentional. And so people recognize that being able to kind of pull the curtains apart and look behind and see how the sausage is made, if it were, really can help to make the science itself stronger and help to advance the science along more. So when we talk about research data management, what we're really talking about is an entire process or a life cycle for the knowledge that's generated from a specific project. You can Google research data lifecycle and you will get, I'm not exaggerating, probably 20 different versions of it. I like this one because it shows that real thoughtful planning around what you're going to share as part of your science starts when you're actually planning a project. Moves through the project startup into the data collection and analysis phases. And then once you've finished a project and you archive this in a repository somewhere where people can find the output of what you've done, that can actually spark new discovery, which can lead to a whole new cycle. I like this particular research lifecycle because it talks about the publishing with the sharing and citing, but also the discovery and impact. And again, as editors, I think that it's good to be mindful of the benefit that your journal is giving back to the authors who are giving you their work, and being able to help them show that people are finding their work and that they're finding it useful and using it as something that's, I think, really helpful for them and also a really important part of the life cycle. So sharing research data has had a long history in this country. And I say that people share it for 2 reasons. First, because they have to, and second, increasingly because they want to. But data sharing in the US in particular has really been a compliance issue more than anything. The current NIH data sharing policy actually dates back to 2003 and said that any investigator that was applying for an NIH grant of more than $500,000 had to include a plan for data sharing or state why data sharing was not possible. And then the requirement went on to say when data sharing is limited, they should explain such limitations in their data sharing plan. This was all that the NIH said about it for decades. And you can see from the pretty bare bones of what the requirement was that there wasn't a lot of help for researchers about why they would want to share their data and what they would actually share. And there's actually a pretty wide open door with an invitation saying, just state why you can't share your data, and then you can get on with your research. And of course, most people chose to do that because sharing data is, it used to be perceived as something that could be potentially threatening. People were worried about being scooped in certain areas. They were worried about people pulling their research apart and finding errors and discrediting them. So a lot of people chose not to share. And NIH has finally, after about 25 years, revisited this, and they've got a new data sharing policy that's coming out in 2023, which actually gives researchers a little bit more assistance in terms of writing a well-defined data sharing plan. And the data sharing plans are actually going to be reviewed as part of the funding process. So we do expect that a lot more researchers are now going to actually be looking into sharing their data because NIH is actually providing them with a little bit more of an infrastructure or guidance about how to do it. Together with this, the International Committee of Medical Journal Editors has actually made data sharing plans a requirement for publication of any clinical trial that's registered in clinicaltrials.gov. So I don't know if you guys have talked much about the ICMJE or if you're familiar with that. It's basically a committee of medical journal editors. So traditionally, some of the biggest journals in the world, NEJM, New England Journal, JAMA, Lancet, the National Library of Medicine, publishing representatives. It's a committee of about 15, I think, at any given time. And they basically come together and talk about what the standards are going to be for acceptable practices and policies in biomedical publishing. And the fact that they're now backing a requirement for data sharing plans and really pushing for data sharing with clinical trials is another indication that we're moving into an area where more people are going to be sharing data because they're not going to be able to get their work published in top tier journals if they don't. Foundation funders have been a big supporter of data sharing for a long time. The Gates Foundation a few years ago actually stated that not only do papers have to be published open access so that anybody in the world could read them, but that the data that supports those papers also has to be made available immediately on publication in order for Gates Foundation funding to be used for that work. So the funder mandates have actually made a big difference in terms of swinging the pendulum. But I would argue that there's actually been a pretty big culture change. And I think we've seen it, especially in the COVID times, towards more openness around the entire scientific process. So we've had editorials coming out in the New England Journal about how data sharing is actually an ethical imperative. Researchers are beginning to understand that sharing data can benefit them because if people have more access to the entirety of their work, including the data, then they can be cited more often, which is very helpful. And also just the whole concept of open science, I think, has been embraced much more readily. A lot of this dates back to the Zika crisis in 2015. It's kind of sad to think about now, but really researchers that were working on Zika were afraid to share what they were learning that could have potentially affected how we were understanding and treating the disease, because they were afraid that if they shared the data, they would not be allowed to publish on it later. And of course, publishing is a big currency when you get into the scientific world. So the World Health Organization actually convened a consultation and said, you know, we need people to share openly, particularly in cases of these global health emergencies. And if people do share their data that can help to solve these problems, we're not going to let that be a barrier to publication. So that was one of the first steps. Within a couple of years of that, Francis Collins, the director of the NIH, actually wrote some blog posts about how we ask patients to participate in these clinical research studies, and then we sit on the data. And it doesn't necessarily do the patients that participated the good that they were hoping to see come out of it. And it doesn't necessarily benefit science if data is not shared. And then again, researchers started to realize that sharing data actually helped with their impact factors, and they would get more citations if they shared data relevant to papers or to work they were doing than just publishing the papers alone. And, you know, people say, well, who cares about how many times you're cited? But unfortunately, everybody cares about how many times you're cited. So it's very important not only to journal editors, because that helps to increase the prominence of their journal. Funders look at this, hiring committees and promotion and tenure committees look at this. So it's not uncommon for us to get requests from faculty that are about to go into the tenure process, asking for their highest cited publications and what the impact factors of the journal was, because this is something that people actually make career decisions on, right or wrong. So as an author, people want to make sure that all of their publications and their data are easy to identify with them as a person. This is particularly important for women who may or may not get married and may or may not change names. So having some kind of a universal identifier that's going to bring all of your work together back to you is really important. It's also very important for people with non-English names that might be very common. So if you have a name that is really common across the world, being able to distinguish your work from the work of another person with the same name is very important. So you want to make sure as an author that all of your work is easily identifiable back to you. And you also want to make sure that there's citations provided. People are happy generally to cite you if you make it easy for them. If they have to figure out how to get your work into a citable form, they don't tend to do that as much. So as an editor, you can take what's important for authors and bring this into your work as well. So one thing that we'll talk about is using an author identifier like an ORCID to help authors associate their publications with them. And this is something that you guys could do even as a policy. You could just say, as you submit your manuscript, make sure that you have an ORCID ID number along with your contact information. The university can help with registrations. It's something that's very easily done. You also want to make it as easy as possible for others to find and cite the material in your journal. So I know that your hosting platform is moving to a different, you're using a different content provider now for your hosting platform. But I would say that one thing that would be really important is either in the HTML versions of what's being published or even in the PDF itself, if you just provide an actual formatted citation that somebody could copy and paste if they wanted to cite the work in the journal, that just makes it a little bit easier for them to cite your authors and give them the appropriate recognition. And then the last thing would be embedded impact metrics that can really add value for authors, because if someone's published with you, he or she can come back 5 or 6 years later and just look to see over time, is their work being noticed? Has it been downloaded? Has it been cited or mentioned in different places? And again, I know you're working with Michigan Publishing, and I know that they've recently switched to a different platform, but just talking with them about what kind of article level metrics could be embedded, that could be a real value add for your authors. So I've talked about open science a few times. And again, open science is not just the results of the research, but also the process. And there's a couple of different pieces of open science that are starting to really be a bigger player in the publishing world. So when we talk about some of the areas of open science, we'll talk a little bit about post-publication sharing, which is what we're used to with repositories. Preprints, which are relatively new. You've probably heard a lot about them during the COVID time in particular. And then some newer types of publications, including ways that you can share code. So when I say that post-publication sharing is tired, I say that kind of tongue-in-cheek. I think that it's an okay way to be able to share data. I think that there's better ways, but I would still prefer post-publication sharing of data to not sharing data at all. I think it can be a little problematic when you get to some of the actual nitty-gritty details, because a lot of journals will say to authors, yes, you have to provide evidence, or you have to either give your data to us and we'll share it, or you have to put it in a repository and give us the link. But with commercial publishers, we don't have a lot of guarantee that they're actually going to curate and archive that content appropriately. Some publication repositories like PubMed Central through the National Library of Medicine, we can be a little bit more confident that that data is going to be around if it's being stewarded by an organization like this. The NIH has some data sharing repositories that we know are probably more likely to be supported. But when you get into some of the data sharing platforms like Figshare and Dataverse, you know, these are commercial products. Some of them partner with academia. They may or may not be around for a long time. So asking an author to, you know, give a Figshare link when we don't know if Figshare is going to be around 10 years from now is maybe a little more problematic. At U of M, of course, we have access to institutional data repositories, and I think that this would be a real strength for the journal. I know that you're going to be using Deep Blue if you're not already with archiving with Michigan Publishing, and Deep Blue Data is just another flavor of a repository. It's built specifically for code and data sets, and I think that one thing that could be good is to encourage your authors, if they're going to have a data set that's going to be made available with the publication, if they use Deep Blue Data, then you should be able to link the data set to the paper and vice versa, and provide them with their you know, downloads and statistics on both in a way that would be really helpful. If they can't use Deep Blue Data for some reason, then a disciplinary repository is a good second guess or second bet. And we have at the University of Michigan, we're consortial members with ICPSR, which is the Inter-University Consortium for Political and Social Research, which on the surface of it doesn't sound like it would be super relevant for you guys, but they actually are the designated repository of record for a lot of the NIH Institute centers and special programs. So if you have someone who wants to share data along with a paper, but for some reason they can't do it in Deep Blue, if, for example, it were to contain PHI, working with a disciplinary repository like ICPSR could be a good option. But again, these are all options really that we tend to traditionally associate with post-publication sharing. What we're really moving into now is an era where we want to share everything related to the science. So we want protocols, we want, you know, more raw data than was published, we want the code, we want to understand how the cleaning and analysis was done. And the post-publication sharing model doesn't really support that as well as some newer models. One of which is the open science framework. So this is an open source resource. University of Virginia Libraries has done a lot of work with this, and University of Virginia. What you can do with the open source framework is actually build your entire project here. So you can have your protocols, you can pre-register your study, you can have all of the data in one place, you can link out to the manuscripts, and it's a nice place or a nice way to actually give people access really to the full workbench that you're working on in the lab, as opposed to just the one carefully curated piece of data that you want to share afterwards. One really nice thing about OSF is it integrates really well with a lot of different products like Zotero and GitHub. You can use it with Dropbox. They've got an integration built in with that. So if you have an author that has an entire project that they'd like to share, something like open source framework would be a really good way to do that. Zenodo is a platform that does something similar. So this is CERN funded, and it's really much more heavily used, I think, in the EU at the moment, but this would be another good option for being able to share really the broad spectrum of what goes into making a paper, as opposed to just sharing the final results. So I want to talk a little bit more now about just data sharing and how the whole idea of data sharing has changed the publishing landscape, but I'll stop a minute in case there's any questions. I know we've covered quite a bit already at the end of what's probably been a long day for some of you.
I just wanted to touch on the slide before Zenodo, and that is just another repository like Deep Blue Data and ICPSR. Or is it
yeah, that's a great question. Not exactly. So what you're going to get out of Deep Blue Data, for example, is Deep Blue Data will take your data set once you're done with it. So you've done your research, you've got a manuscript that's been accepted, or you're working on your manuscript. But as far as your data is concerned, you're done. Like, you're not going to run any more analyses. You're not going to do anything else with it. That's when Deep Blue Data wants it, because Deep Blue Data is traditionally an archive. And what you expect when you go to Deep Blue Data is that if you go to, Marisa's data set of 2021, that it's going to look the same in 2022 and 2023, because I'm not continuing to work with it. What you get with Open Science Framework and Zenodo is this can actually be the platform where you're doing your work. So if people wanted to look at not my final data set in 2021, but they wanted to see maybe a version history of how my code had changed between 2020 and 2021. That's something that Open Science Framework is really much better at, because of the way that it handles different versions and the fact that it's not expecting final research products to be delivered there. Also, just the fact that it's an entire kind of project management ecosystem. So again, it's got a setup for protocols. A couple of years ago, they ran I guess you'd call it a promotion, where they had financial incentives to pre-register your research. There was a problem in some research communities. They would call it p-hacking, where basically people would go through and they would do their research, and then they would just comb through the results to see what had statistical significance, and that would be what they would report on, regardless of what the hypothesis was that they were investigating in the first place. So the idea that Open Science Framework had was, if you pre-register your hypothesis, then we know that we're getting your actual results, which might in fact be negative, and that could be really valuable, as opposed to just what you're cherry picking in order to get it published somewhere.
And are these, the Deep Blue Data, I'm assuming, is free for us to deposit our data in. Is this product and Zenodo, are those something the institution helps cover, or are these free?
That's a great question as well. So OSF is free. It's one of those, it's kind of like Zotero is free. So Zotero is free unless you want the storage, and then you pay for the storage. It's the same with OSF. So if you were to use the actual OSF project management site, you get, I don't even remember what the data limit is now. I'll make it up, 10 gigs of data. And if your project's going to exceed that, then they want you to actually pay to use their servers. But they also offer all of these integration options with Dropbox and Google Drive and things like that, so that you don't have to use their server space. They have a lot of different, so OSF is actually, it stands for Open Science Foundation. I don't know if I said that earlier, run by the Center for Open Science, and they run infrastructure for open conferences. They have this OSF platform that you can use for your research. They run a lot of different services, and some of them, like the conferences, are fee-based.
Thank you.
Yeah, great question. Thank you. I'm going to pull my shade down really quick because the sun is starting to bother me. So just get that done. I'm usually not at my desk this time of day, so I didn't expect that. Okay, so a little bit about data sharing and publishing. And one of the things that I think really started moving away from just the post-publication sharing of data was the idea of preprints. Preprints, and in the NIH world, you hear them referred to as interim research projects, are basically manuscripts that haven't been formally accepted and published yet, but sometimes they're looking for a home. Sometimes people just want to get the information out to be able to share it. And they've really had a pretty meteoric rise. So the image on this slide is from a story in Science in 2017. And you can see just people were kind of bubbling along. It really took off first in some of the basic science communities and in physics. That's where you saw a lot of this preprint work being done. And they would use a repository called Archive. It was run out of Cornell University. They would put the manuscripts in there as preprints. One of the reasons for it is that there could then be this kind of open community peer review and dialogue around the results, and the results could be transmitted without having to wait to go through a publication process. So you as editors know that it can take a long time to get something out into print. You have to have it accepted, which means you have to find reviewers, and then the reviewers have to review it, and then there might be revisions. And depending on a publication cycle, it can actually take quite a long time. And sometimes we need the results a little sooner. And that was certainly the case with COVID. And I think COVID really changed a lot for the biomedical publishing landscape. So there was a companion site to Archive called BioArchive or medRxiv that started up. But especially clinical researchers were understandably very reluctant to put clinical research out that hadn't been properly peer reviewed and vetted through the cycle. But COVID changed a lot. So this is from a PLOS article that was published very recently and really shows as the cases and the death count for COVID started to rise, you started to see journal articles on it rising, but at the same time, you saw a corresponding rise in preprints that we really hadn't seen before. And a lot of that was people saying, look, we think we have really important, relevant information here, even if it's a case study or a case series coming out of our institution, some lab findings that we have through bench work that's being done. We want to share this because we want to contribute to solving this global problem. And what you can see on the bottom, that's just a list of some of the different repositories that were publishing preprints. And medRxiv, which was the Archive spinoff that I mentioned earlier, has a pretty big market share of this. There's also increasingly journals. So this eLife is a relatively new publication that I think it's worth keeping an eye on for innovations within the medical publishing sphere. eLife is now saying that they will not accept manuscripts for consideration that have not been submitted as preprints. So this is something that's a little bit different that we haven't seen before. What we saw initially was journals saying, well, why would I want to accept something that's available as a preprint because people have already read it? And eLife is kind of turning that around and saying, no, we actually don't want something that hasn't been submitted as a preprint because we think that that's a valuable piece of the scientific conversation. They've also talked, eLife, about being preferential in the future towards accepting final research results where they've had access to research materials all the way through the study. So if an author chooses to publish a protocol, a methods paper, they would get priority consideration at eLife when it came to publishing the final results. And the view of their editorial board really is that the final results are only such a very small piece of all of the science that's gone into this. And why don't we want to see the entire thing instead of just looking at what a group of authors may or may not have kind of cherry picked to be the final results. There's also different types of journals that are cropping up now. So data journals have become a thing that it would be worth looking into. What data journals will tend to do is publish either data papers or methods papers. So these are papers where someone is either describing a data set that they've generated and how it can be used, or they're describing the methods that they use to generate the data set. So they're not reporting on results, they're not reporting on an analysis of results, it really is purely the data and the methods. And again, if you think about how you want to market the Michigan Journal of Medicine, this could be something that could be really attractive for a subset of authors. Maybe they don't feel like they have results that are worth reporting on or that they're ready to report on, but they do have a data set that they can describe, or they do have a methods paper that they could publish, and being able to offer that could be a way to increase submissions to the journal. So this is just another thing about what data papers do. So again, that they don't provide an analysis or they don't provide results. They really are just describing the paper itself, and just gives you an idea. One of the reasons that we talk about things like data papers or executable publications, which I think I talk about on the next slide, is that it gives authors, again, a different way to share the knowledge in a way that they can be cited for. So what this graphic here shows is that in the past, an institution would give money to a researcher. A researcher might create code or a data set or a data package, and then that goes and lives in a server somewhere. Another researcher can pick it up and write a paper, and maybe they remember to cite the original data set, but maybe they don't. And then the cycle goes there. Whereas if you actually have a researcher that can generate the code or the data set and publish that in a data paper, then it actually accrues benefit back to the researcher much more quickly than having to wait for someone else to notice their work, use it, hopefully cite it, and then get back to it that way. And if you think about it, sometimes there's much more value in the method, the piece of code, the data set itself, than the results that come from it. So thinking about data papers, I think is a good way forward. These executable papers are, this may not be something that you want to get into because you then have to figure out how you're going to test the code yourself. But the idea of an executable paper is that it's going to have some code contained in it so that someone could actually run the model either with data provided in the paper or with their own type of, if they had data that would also fit into this model, that they would be able to actually use that themselves. This is something that is, people talk a lot about it. I haven't seen it done very well, very frequently. So there's another open source journal or open access journal that's published out of U of M, the Journal of Learning Health Sciences, which talks about computable knowledge papers, which in effect are supposed to do this. They haven't had too many submissions yet, and I haven't seen them publish one, but I think this is something to potentially keep an eye on. Maybe for the people that are M4s right now, maybe they're not going to see these come in, but if you have M1s, M2s doing reviews, maybe they'll see some student submitted executable papers in the next couple of years. A third type of publication that people are starting to talk a lot about now are these nanopublications. And nanopublications, instead of having an entire study that you're reporting on, it's basically one assertion and the data that supports that assertion. So the link here takes you out to nanopub.org, which breaks down, it's basically an RDF metadata schema for how you would validate the knowledge that's being talked about in this nano publication. But there was just a conference last month, the National Institutes of Health, some representatives from their Translational Science Institute, together with some publishers, were talking about what they're calling Litcoin, which would basically do the same thing. So it would take smaller pieces of knowledge, provide the provenance and the data that would back up the assertion, and publish these as little micro publications. All right, so with all of that information, what can you guys do? And I think that one of the things I would really encourage you to do, obviously by talking about these newer types of publications, I really did want to start, stretching your minds as to what are the limits with the current publication system, and really what could you guys do, if not now, in a few years, to maybe start innovating away from that. Sorry, Sam, I hadn't seen your hand up.
Oh, I had a quick question. Because this is a lot of new learning, which is good. What was RDF? What does that stand for? And then the nano publication, could you just explain just a little bit more about that?
Sure. RDF it's a metadata schema. I think the RDF actually just stands for resource data format. Now that I've said it, I'm rethinking myself, but basically it sets up, it's a metadata schema that works in the concept of triples. So if you have, it's like a subject predicate object kind of thing. And it's a way to be able to uniformly describe things that aren't at all the same. So a lot of metadata standards use these RDF triples as their basis. So what the nano publication does is it talks about It's going to have an RDF schema that helps describe the assertion that's being made. And then the provenance talks about how they figured that out. So that can include everything from the lab it came from, the dates, creators, maybe instrumentation, depending on what the actual assertion is. And then the publication information piece of this would then route you out to the broader body of information that's available here. So that could be a published paper, it could be a website, it could be a GitHub site, you know, whatever contextualizes that bit of information.
So it's really just a play, like almost like small ads for papers on a website of all different types of topics, but then you can go to the little ad for the nano publication to connect to the full one. Am I understanding that correctly?
So I don't think, and again, this is a really new area. And if you look at the examples that are on that site, they're not even all from one discipline. So I think it's being done in different ways. And I think it's resource description framework is what, I think that's what RDF just popped into my head. So sometimes they will link out to broader papers, like full papers, but sometimes it's really just the assertion itself that's being picked out. And I think that this is used, or they think about this being used in order to help with replicability instead of reproducibility. So there's two different reasons really to share data. One would be reproducibility, that if I've done something and I say, yeah, you know, here's my code, here's my data, you can take my data and you can run it through and you'll get exactly the same results. When you hear talk about the reproducibility crisis, particularly in psychology, that's because people tried and they couldn't get exactly the same results. So when you're trying to reproduce research, you're really trying to do exactly what the authors said they did in the way that they said they did it. With replicability, what you're trying to do is really continue to advance an assertion. So there's a model that will, like, it's a little pie chart and it shows hypothesis one as maybe 25% of the pie chart. And then as replication studies are done in different, in different ways using different types of data, hypothesis one gets a bigger and bigger piece of the pie because all of these different studies have been able to confirm that hypothesis in different ways. These nano publications, I think, tie much more to the replicability than they do to the reproducibility. Yeah. So when they were talking about it at NIH, for example, I'm trying to think of one of the examples they used, but they would talk about, if they had particular bench findings about a certain protein, that they would be able to kind of segment out the salient points about that protein. And those could be little individual nano publications that maybe somebody could take and use in an executable way, or maybe they would want to use that in a piece of code. Whereas if it was in a research paper, maybe that level of detail wouldn't necessarily be published. I'm not sure I did a great job answering that question. I can send the link for the Litcoin conference because they had some speakers, including from PLOS, some of the bigger journals that are looking at this, and Elsevier, that had more specific examples that would probably be more helpful than me trying to fumble through an explanation.
No, it worked. I just have to sit and let myself be marinated with the information.
Okay, where was I? Okay, yeah, so I think, and actually what you just said, I think is exactly one of the things to do, is just start to think through these things. You're at a point in your training where you've seen, 1.5 million book chapters at least, and you've probably read at least 3 million journal articles, and you're very used to that as a form of scientific communication. But even thinking in terms of your own learning and your own practice and your own research, what other ways to disseminate information could actually be more effective, and how could those translate into a publication framework? And I think that's exactly what the publishers are doing right now, the big publishers, as they grapple with this, because most people aren't reading full papers anymore. They read the introduction, they skim the methods, we hope, they look at the results, and then they try and get what they need from it. But maybe what they need from it is the author's address so they can write and ask a question about the code. So I think that publishers are looking for ways to be able to provide value by maybe looking more broadly at the entire scientific life cycle than they had in the past. So not focusing just on research results, but maybe also looking at things like protocols, methods, and things like that. and also looking at different ways that research results can be disseminated besides full-length papers. And there's a whole diversity, equity, inclusion conversation that can be had about this too, about who's excluded when we focus just on published research papers as a method for transmitting information. And I think that that's an important piece of the conversation as well. So bringing it all back around, I think the marinating is actually really valuable, just looking for different types of publications or different trends that you see out there, and thinking not only how do you channel that into your work with MJM, but what does this mean for you as a researcher if you choose to make that part of your career path. So some of the things that I think that MJM could do, or that the editorial board could do, is to have some conversations around these emerging publication types and think about some new policies or procedures or workflows for the journal that you could pass on to authors. One beneficial thing could be to develop and enforce a data sharing policy and say that if you have people that are going to be publishing original research in your journal, that you have an expectation that they share data in this way, and here's how. I don't know what your content breakdown tends to be, so that might not be a good next step for you, but it's something to consider. And then again, consider soliciting and publishing new publication types. So having a look at some of the data papers and maybe somebody has a data set that they would like to describe, or maybe they have a method that they've worked out that they would like to describe. Maybe they've got code, maybe they've written a package, and it's a good thing to have in a journal, in addition to hosting on a GitHub site where people can grab it and use it from there. Another thing to consider might be policies and workflows around publishing preprint. So I know that you've moved to, I think you publish annually now. Is that the publication model? So is there space there for some kind of a preprint model where people could get the work out and in the public eye a little bit faster, even as it was moving through your publication process? And maybe that would be something that the editorial board would want to learn more about. Another thing that I feel really strongly about is thinking of some policies or some workflows that you can use to help authors benefit from publishing with you and from sharing their data. So we talked about one way earlier, which is to collaborate with both of our institutional repositories. So Deep Blue for the human readable stuff and Deep Blue Data for the machine readable stuff for the data. And if you can get people to deposit their data into Deep Blue Data, you can add value by linking the published papers to the data sets and vice versa. So that if I'm in Deep Blue Data and searching and I see this great data set, I would actually have a one-click access over to the paper in MJM, and I could read that there. We talked a little bit about providing formatted article and data set citations so that your authors have a way to be cited when their work is found. Again, you try to ascribe best intent to people, but they won't always take the extra step to figure out how to cite something if they're not familiar with it. So if you can make it easier on people, that's a benefit to your authors. We talked a little bit about providing some article and data set level metrics so that people can click onto their pages and see how many times their work has been accessed or downloaded. And then again, I would encourage, if not require, your authors to have an ORCID ID. So you can just go to orcid.org, you can set up a profile. It's basically like a social security number for researchers, basically. No matter how many times you change your name, move institutions, it's something that follows you, and it's a great way to aggregate all of your work into one place. If you were to require this of submitters, it's one step that they take that can really help them throughout their career. And then I would say to also train peer reviewers as you're going through and teaching people how to do the peer review of the manuscripts. Give them some training about how to review data as well and what to look for. We're just going to go over this really quickly now, but I can certainly meet with you guys or do a little training for people. But one of the first things that you would want to teach them how to do is how to verify that there is a data set submitted. So it could either be submitted with their manuscript, or they might give a link out to where it's being stored in Deep Blue Data or on an OSF website or something like that. And really, insofar as you can, do a peer review of the data set as part of the peer review of the manuscript. So in some ways, it's no different than editorial boards that have a separate statistical editor that will go through and run the statistics and make sure that the proper test was chosen, that it was done in the right way. You're just applying that same kind of expertise to a data set. Some of the best practices to look for, we very much prefer non-proprietary formats. So if they submit a data set in a proprietary format or that's been generated in a commercial database that you can't get into because you don't have a subscription, that's not going to be really useful for readers either. If you can get into a data set, you definitely want to look and make sure that you understand what the variables are. So if they have column headings like X1, X2, X3, without a data dictionary or some kind of a code book, you're not going to know what those are. So you want to make sure that you've got all of the supplemental information that's needed to understand the data set. You would want in the manuscript to know that the procedures for both the analysis, but also the cleaning of the data have been described. So if they've gone through and stripped out a bunch of variables, or if they haven't included things outside of a certain range, that should be stated in the manuscript. Source code could be included or linked to, but at the very least, you would want to know what versions of software were used for the cleaning and analysis. And also, particularly with something like R, if they used specific packages, those can be stated in the methods. They can also be cited, which again is just a courtesy to the authors who spent a lot of time creating them. But really the bottom line is you're just looking for well-organized and well-documented data. So if you as a reviewer are looking at it and you can't understand it, readers probably aren't going to be able to either. And that could be something that you could make some suggestions on in terms of the revisions. Not that you want them to revise the data, but that you want them to revise how it's presented so that it's a little bit more accessible to people. So despite my best of intentions and taking out a whole chunk of the presentation from last time, I feel like I've still taken us a little bit longer than I wanted to. The last thing I want to leave you with is that we at the library, my team and me personally, we're here to help. So as you're working both as editors and as authors or researchers of your own, if you have questions about how to find data, what some of the best practices are around data management, including versioning or anything around data management, the planning, creating your documentation, working with metadata to describe it. We have a lot of training around the different platforms for data analysis and data storage, including electronic lab notebooks that are available at the university, data visualization, which we've already talked about, how you can create a citation format, and then archival data curation for where you would want to store data at the end. But that is my talk. I'm happy to answer any questions now, recognizing that we did cover quite a lot. Please do also be in touch if questions come up later.
A question for you. So you touched briefly upon like more open data formats. So with some publications, people will do their data sharing as sort of the supplemental information within that publication versus like open sharing. I know sometimes they can be, it's a pro and con because more people will see the data, but then at the same time, it tends, I think in some cases, to become de-linked to the original publication. So perhaps less citations. Do you have any pointers for better ways to connect those two to get that open sharing, but also encourage people to cite the original article, especially as we're thinking about articles that we're reviewing that might be pulling from big data resources, open data that's available to the authors that are submitting it?
Okay, so let me make sure I understand the question correctly. So you're talking more about how to prevent the disassociation between data sources and the article itself?
Yes.
Yeah, it's a problem. There's unfortunately no easy way to do it because the methods that are being done right now are either a journal will ask for the data set and they say, oh, we'll publish it, until, either until they don't because they go out of business or, the journal gets bought by someone else, or that then creates the problem of maybe you don't subscribe to that journal and then you don't have access to the data or the paper itself, because if you try to get the paper, maybe you can get the paper through interlibrary loan, but the supplemental data is almost never included if you get an interlibrary loan. It's almost always like a PDF of the paper. The only other option then, and that's where people kind of go all different ways, is people are kind of tasked with finding their own repositories. And if you're at somewhere like U of M that has a very well established institutional repository, that's a little bit easier because at least the data aren't going to go anywhere. And there's almost always a way to get a link to the paper from the data if you have the data in Deep Blue Data, they will almost always accept a citation to a published paper. The nice thing about institutional repositories too is they'll generally generate a DOI or digital object identifier, which can then be published in the paper itself. So some journals actually have a requirement that you have a DOI for your deposited data set before they will accept the paper for final publication, which is great if the DOI is being generated by a repository that you have some confidence is going to stick around. And that's one of the issues with things like Figshare that could get bought out at any time. It's potentially an issue with any resource. You know, there's no guarantee that any of these platforms are going to be around, but that's one of the really nice things, again, about both Zenodo and OSF, is because you're dealing with an entire platform, they have spaces both for the DOI for the data set and the citation for the paper. It just requires that the authors go in and link those two together there. So I would say, bringing it back home for you guys, probably the simplest thing would be using Deep Blue Data as the data source. And then getting that DOI, you could then publish the DOI in the paper and then give the citation for the paper back to Deep Blue Data, and then maintain those links that way.
Gotcha. So it would be a two-way street, basically.
Yeah. You're basically taking information about one and making sure it's embedded in the other resource. Yeah.
I had one other question for you about these sort of other publications that you're talking about for the like nano publications and sharing coding and such. Are those usually done as like a different type of publication within the same journal, or is that usually a separate journal?
That's a great question. So there are a couple of journals that will do that. Let me pop back. So I think one of the slides was the journals. So BMC Research Notes and then Scientific Data, which is part of the Nature family. Those are journals that are actually only going to publish that thing. Some journals just won't accept material like this. Like they have very, you know, you can go to the instructions for authors and they'll say, you know, we accept research reports that are 4,000 words or more and report on the results of an original, you know, they'll describe it, but there won't be any format for a data set description or a methods paper or things like that. So if we're working with faculty, for example, that are looking for places to publish, if they're doing this type of work, they tend to already know what their target journals are, but we do like to just let them know. We really spend a lot of time marketing more to the people that don't know that this is even a thing, you know, that they spend a lot of time doing these code packages or things like that and don't know that there's these alternate publication venues that they could be using to publish not only their original research, but also the methods that got them there. So that's where I think that, you know, even adding that this is a type of paper, you know, if you talk through this at your editorial board meeting and think, you know, yeah, we probably could get some expertise that could do reviews of data sets or could do reviews of methods papers, then I would definitely add that in your instructions for authors that these are types of papers that you are willing to publish.
All right. Does anyone else have any further questions?
Oh, no, this is great. I just wanted to say thank you. And I'm probably going to be emailing you again to learn more about training for data sets. I think that would be really helpful.
Yeah, I would actually, you guys could be my test audience for this, because we've had conversations with individual reviewers, but never actually done a full peer review training about what to look for in data sets. So I think that could actually be a lot of fun. So, yeah.
Well, thank you for spending this time in your evening with us. We really appreciate all of the guidance and support that you provide to us. And this was a ton of really great, useful information. So
excellent. Well, thanks for having me. I know it was a lot. I always think that I'm cutting things back and then I end up still with more than I thought I would have. So I hope it wasn't too much. But again, if there's questions as these sorts of things settle in, we're happy to support you in any way we can. We really admire the work that you do and we're happy to help.
All right.
Thank you so much.
Great. Have a good night, everyone.